The steps are the same. Test n equals 1. Or prove true for n equals 1, alright? So you say 6 power 1 take away 1 is, what is it? 5, alright? And then 5 divided by 5 is 1. See the way it divided, the answer divided in equally? This means it's true for n equals 1. Happy out? Alright, so that's the first part done. So the first part is step 1. That's done in black, and that's quite easy. Now we're going to move on to step 2, which I'll put over here in blue. It's the same. Assume true by for n equals k. Now I wonder, we don't use mod, do we now? It used to be the way of yeah, it used to be the way we used to show that as divisible, but anyways, we'll do it this way. 6 power k take away 1 is divisible by 5. I'm going to rip off the whole language, yeah, for k elements. See why I'm just using the question against itself. Alright, now what are we going to do for part 3? Prove true for n equals k plus 1. Alright, so what is it this time? 6 to the power of, anybody? Take away 1. Alright, now what is 6 to the power of 6? What does that actually mean? So the skill is in creating, the skill is using part 2 in part 3 every time. Okay, so you got to recreate part 2 in part 3. Alright, so I'll explain what I mean by that. Do you remember the rules of indices? So what can I say 6 power k plus 1 is? 6 power 1 by 6 power k. Would you be happy enough with that? Which is 6 times 6 power k. You happy enough with that? Now, so that's 6 by 6 power k, take away 1. Now I need to recreate this system here. So here's what I'm going to do. I'm going to put 6 power k take away 1 over here. How many of them are left then?
6.
5 of them. Okay, I see where you're getting mixed up, alright? I have a way of explaining it. See this system here? Imagine that's 6y take away 1. Do you get what I'm saying? And I break that up into 5y plus y take away 1. That's essentially what I'm doing. So I'm doing 5 times 6 to the power k plus 6 power k take away 1. You don't get that, do you now?
No.
Hands up if you don't get it. Alright, that's too many of you, so we'll try and explain it a bit better next time, alright? So this number here, see 6 power k 6 1, alright? That means 6 power k multiplied by 6, which is 6k's. Alright? And I can break that up in any way I want. I can say 6 by 6 power k is 4 of them plus 2 of them. I can say that, can't I? Do you just get that they're the same thing?
Yeah.
4 6k's plus 2 6k's is 6 6k's. Everybody cool with that? Now, I want to break it up in such a way that it's divisible by 5. So I'm going to use 5 and 1. And that's what I did over here. Does everybody see that I broke it up into 5 and 1? Have I lost anybody with that? You sure? Okay. Now, there's 2 separate parts to this. There's the green part here. And, sorry, the green part would end before the plus. The green part here and the blue part here. We happy enough with that? Why is the blue part divisible by 5? divisible, assumed divisible, assumed divisible, wasn't it? That was part 2, no? Assumed divisible by n equals k. Now, 5 times any number is divisible by 5. And see the way it's 5 multiplied by 6 to the power k. So 5 is divisible by 5. So what you say, therefore, I used to use P of k plus 1. Therefore, n equals k plus 1 is true if n equals k is true. Hence, by the principle of mathematical deduction, it's true for all values of n. What did we say yesterday? Is that word for word the same thing, or is it slightly different? Same thing though, right? Yeah. Same gist. Right. Alright. Step 1. What's step 1 again? Prove true for n equals 1. So prove true for n equals 1. 9 to the power 1 take away 5 to the power 1 is 4. 4 divided by 4 is 1. Hence true. Therefore, the 3 dots means therefore true for n equals 1. We cool with that? Easiest 5 marks you'll ever get. Okay. In a way, induction's great for 50%. Right. The second easiest 5 marks in the full leaving cert. What do you do now?
Assume true for n equals k.
Yeah, assume true for n equals k. Were we calling that P of k yesterday, were we? No. Same thing. So 9, and I'm just going to rip off the exact wording of the question. Now, the next part is where you have to be good with numbers in your head and you have to sort of see a pattern. It is difficult. I haven't done one of these in a while, so this will be fun. Alright, so what we're going to say, prove true for n equals k plus 1. So what we're going to say is 9 to the power of k plus 1 minus 5 to the power of k plus 1. And we want to prove it's divisible by 4, don't we? Alright. We're going to do what we did last time. What did we do last time? We broke that into 9k's. Is that alright with you guys? It's the same trick as last time, isn't it? 9 to the power 1 by 9 to the power k. What do you think you're going to do for the 5s then? Same trick, right? Now, the key number is 4. See the 4 there? Okay, I could really do with trying to make it 4 somewhere as well. That'd be handier, right? So here's what I'm thinking. See that 9? Here's my suggestion. I'm going to break the larger number of the 2. I'm going to break that up into 4 times 9 to the power k plus 5 times 9 to the power k. Now I instantly have a good feeling about this one. Can anybody explain why am I getting a reasonably good feeling straight away? The 5s can't cancel. That's like saying 5x minus 5y. and the 5's just cancel. They might factorise out. I think is that what you're trying to say?
Yeah.
So the 5's will factorise out is a good call, Phelan. It's an excellent call. It's exactly what you're going to do. So factorise out the 5's. Alright? And we'll do that now. So I think the rule there was I went after the larger number of the 2, and then we got to factorise out 5. Okay, so there we agree there's 2 parts to this, isn't there? Okay, and if you're in an exam you can't exactly use highlighter too good, so I'll say red part and blue part. You happy with that? Why is the red part divisible by 4? 4 is divisible by 4. And what about this part here? 9 power k minus 5 to the power k. What did we say earlier? Assume divisible by n equals k. So 5 multiplied by any number that is divisible by 4 will result in a number that's divisible by 4. 4 times any number will result in a number that's also divisible by 4. So basically this green section is covered because 4 times any number results in a number that's divisible by 4, and this red section is covered because 5 times any number that's divisible by 4 will result in a number that's divisible by 4. Charlie?
Are you giving marks by a little writing at the end?
Yeah, absolutely. Yeah. And what did I say yesterday? Therefore, n equals k plus 1 is true if n equals k is true. Hence, by the principle of mathematical induction. Because we proved that 1 is true, didn't we? And if we proved that 1 is true, then you say k equals 1 is true. That means k equals 2 would be true. And then that will result in k3, k4, k5 all the way up. Okay? And as we said earlier, n equals k is true. And if we set k equal to 1, then n equals k plus 1 is true. And because k is 1, that means n equals 2 is true. And then if n equals 2 is true, that means n equals 3 is true. You don't even have to explain that part. That's what it means by principle of mathematical induction. That explains that. So hence by the principle of mathematical induction, it's divisible by 4 for all n element n. All natural numbers. Is that right? Or you can just say what I said yesterday. Problem is I can come in behind you on this, the usual. Just well, that didn't make the video, wasn't it? Now, test n equals 1. 10 to the power 1 minus 2 to the power 1 is 5. 5 divided by 5 is 1. True for n equals 1. Alright, just going to get rid of that step then. We're going to go for step 2. Assume true for n equals k, such that 7 to the power k minus 2 to the power k is divisible by 5 for all k element n. Okay, now we're on to part 3. Prove for n equals k plus 1. 7 to the power k plus 1 minus 2 into k plus 1. That's 7 times 7 to the power k, because that's 7 to the power 1 by 7 to the power k. Alright, and minus 2 by 2 to the power k. Keyword, see the 5 there? And see the difference between 7 and 2 is also 5. I think that's no coincidence. It's like a perfectly designed question. So we're just going to break up the 7 to the power 7k into what? 5 and 2. Okay guys, now what we're going to get next here guys is the following. We're going to get let's factorise that out. 7 to the power k minus 2 to the power k, and then that's 5 times 7 to the power k. Now this should come out handy enough. We know this one is divisible, don't we? Because 5 is divisible by 5 is divisible by 5. Is that okay? And what about over here? This is assumed divisible by n equals, assumed divisible by 5 by n equals k. Okay? So therefore, by the principle, therefore true for, while I'm writing this down, have a look at 9. Okay? True for n equals k plus 1 if n equals k is true. Hence by the principle of mathematical induction, it's true for all n element n. Happy days. Right. So lads, look. 7 to the power 1, 4 to the power 1 is 11. 11 plus 1 is 12. 12 divided by 6 is 2. Write it out formally. It works for p of 1. Is that okay? Now assume true for n equals k. Assume true for n equals k. 7 to the power k plus 4 to the power k plus 1 is divisible by 6 for all natural k numbers, k element n. Step 3. Prove for n equals k plus 1. 7 to the power k plus 1. Now this one's going to be difficult. 4 to the power k plus 1 plus 1. I think we do what we always do, and hopefully something will get inspired. Probably not, but alright lads. What are we trying to prove? It's divisible by 6, is it? Spicy meatball. 6, 1, 3, 1, really?
How does this even work?
Just give me a sec. Ah. Yeah, this is an interesting one now. So look. Yeah. So they went with what they went with last time. Do you remember you break up the big one? Now you break up the big one so that it has a 6 in it. So what we're going to go for is 6 times 7 to the power k. Is that alright with you guys? Alright. And then what we can do next is that will leave over 7 to the power k, won't it?
Yeah.
You happy with that? I think if we take out 4 to the power k, so we change 4 times 4 to the power k. I'm going to change that into 3 times 4 to the power k.
Yes.
Plus 1 times 4 to the power k. Now you're probably asking me, why am I doing that?
You multiply by 2.
Just give me a sec, please. Now I'm basically trying to recreate that to get rid of the 1. Is that alright with you guys? Now, got it. Yeah, I have it. Alright, and I'll explain how to I have it, but it's tricky. Alright? Finally makes sense. Now, sometimes you just need to chill, let the answer come to you, let the brain do the work. I know that doesn't work for a lot of you, but works for me on occasion. Now, what we have here is we have 3 parts are good. Alright? Sorry, 2 parts are currently good. Why is this good? 6 divided by 6 equals 1. Okay? Why is this one good? Assumed true by n equals k, n equals k. Now, this one here, wouldn't it be fantastic if that was a 6, wouldn't it? Is there any way you could turn it into a 6? You're not allowed to multiply by 2. But what could you do? Well, why don't we do 3 times 2 to the power 2? What about that? Okay. Now let's see. I mean, I thought I had it, but now I am so sure. All right. I wonder, would you actually have to recycle that and prove that it's divisible by 6, also by induction? Just give me a sec. Alright guys, so what was I thinking? 3 times okay. Alright, good news. We can explain our way out of this, okay, which is great. Let me explain. I'll check the formal solution in a second, right? So, lads, you're just delaying me at the moment, alright? Formal solution just says it's divisible by 6. It just says, it just goes, the formal solution just goes, that's divisible by 6. End of story, alright? Now, you could actually, what you could say here is that you could just go back up and say k is an element of n. So where does k start? 1. So what's the lowest value? 3 times 4? 12. 4 to the power 2? 16. 16 times? So it'd be 48, won't it? So what you can say is that 3 times any even number. Is 3 times any even number divisible by 6? It is, isn't it? So what you can say is, the way I'd explain it is 3 times any even number is divisible by 6, and all 4 to the power k is even. Does that make sense? It's better than what they gave me here. They just said 3 to the power of 4k is divisible by 6, no explanation. Okay? So let's take some questions there. Go for it. Go on. So it's true. N equals k plus 1 is true if n equals k is true. Hence, by the principle of mathematical induction, it's divisible by 6 for all n element n. Awesome. Now here, guys, for your homework, we did, what did we do today? We did, what did we do? 1, 3, 5, 9. Okay. You guys try 2, 4, 6, 8, and 10. I will take it from there tomorrow.